Hello, my name is Kirti Kiran Kame from TY B Division CSC branch. Today I am going to explain you about a topic of language processing system, in that compiler, assembler and preprocessor. So we will take a overview of language processing system. So end to end translation flow, in that a source code passes through preprocessor, compiler, assembler, linker and loader, gradually transforming high level language to the low means in executable binary ready for execution by an operating system. Roles of languages and tool chain concepts clarifies each tool's roles, differences between high level assembly and in machine languages, and contrast translation with interpretation along with the compiler based language processing system of toolchain. Components of the language processing systems are core components and responsibility, modality and information flow. In these core components, editor, preprocessor, compiler such as are testing with distinct primary responsibility. Editor and preprocessor operate on human readable source code. So in modularity and information flow, tools communicate through source files, object files, libraries, components. These components are flexible, builds debugging workflows. Roles in software development, language processing system, automate source translation, enforce syntax rules, integrate with build tools to reliable convert human readable code into executable artifacts across the environment. Key concepts: core language processing concepts, program structure and linking task. Preprocessor, the first transformation state. Preprocessor transforms source code text before compilation. Means it before writing any code, then it compiles the source code, performing directive based text operation without full semantic understanding, shaping what the compiler actually needs. So it reads key behavior and language context. It reads language specific inputs such as C or CPP files. Means key behavior language contents. We see a text regarding to our program, and inputs such as we put that .c or .cpp files and save it to our expanded source, and mistake at the stage often service a later on confusing compile time errors. Core preprocessor features: preprocessing flow and examples. Preprocessing steps overview. Compiler, from high level code to assembly. Compiler architecture and phases: middle end, back end. Optimization to code means transform code into intermediate representation, applies optimization, then generates a target specific machine code. Symbol table and error reporting service span these layers continuously. Front end source analysis layers performs lexical syntax and semantic analysis, building intermediate structures, maintains symbols table, and initiates early error detection across the initial compilation stages. Detailed compilation flows from source code to assembly output, and key compilation stages and examples. Assembler and integration into toolchain. Assembler is nothing but translate a human readable assembly language into a machine code, reading a symbolic instruction and producing object files that can be linked into executable programs. Key characteristics and syntax: it handles instructions, registers, labels, and directives like data, text, global, supporting different syntax such as AT&T or Intel, while still generating equivalent machine code. Assembly to object code flow: assembly parsing and translation, object file generation and relocation. End-to-end example: put it all together. Visual pipeline from source to executable. Use tiny C program and diagram showing executable each arrow and labeled with a tool name, main transformation and potential diagnostic message point. So thank you.